Hi, welcome. In this tutorial, we will learn how to perform a simple SIS model in R. Before we get into the coding, I will briefly describe an SIS model, which is an abbreviation for susceptible-infected-susceptible model. The SIS model is used to model infectious diseases with no immunity. In other words, for such a disease, the individuals within the population can be infected multiple times. No one is immune from getting the disease. So when you have a case like that, you can group the individuals within the population into two classes, infected and susceptible. It's either you have the disease or you are susceptible or capable of getting infected. Examples of such diseases include the rotavirus, some sexually transmitted infections like gonorrhea, and other bacterial infections. So a clear distinction that I can give is that these kind of diseases are not something like COVID, where infected individuals who recover from the disease become immune to infection for some time. Okay, that was just a little introduction. So the differential equations I would use in the model in R are the S dt and the I dt. The S dt, I would use that to model how the number of individuals who are susceptible to getting the disease change over time. And that is dependent on the proportion of infected people that recover from the disease minus the proportion of susceptible who gets infected. So the gamma represents recovery rates. The I represents the initial proportion of the population that are infected, and beta represents the rate at which disease transmission is occurring. And finally, the S is the initial proportion of the population that are susceptible. So the I dt is used to model the number of individuals who are infected over time. And this depends on the proportion of susceptible who gets infected minus the proportion of infected people who recover from the disease. Now, let's see how we can model this in R. The packages we need here are the solve, a package in R for solving differential equations, R shape 2, another package for transforming data between the wide and long formats, and the last package is Ggplot 2, a package for plotting graphs. An IS book on modeling infectious diseases that I have been using and will be using for most of the tutorials is Modeling Infectious Diseases in Humans and Animals by Matt Killing and Pejman Rouhani. This is not an advertisement for the book, but I will say it's a great resource for modeling infectious diseases. They also provide codes in C++ program, Python, Fortran, and MATLAB, but sadly not in R. So that's where this tutorial comes in handy. So the first thing that I'm going to do here is to define the state values. And that includes proportion of infected and initial proportion of susceptible. I use the same values that are given in the book. So I is given by this value, and susceptible is simply 1 minus I, because when you calculate S plus I should give you 1. So I put that as my state values, and I'm going to run this. Once you run it, you should see it appear in the global environment, within the global environment section. The next thing that I would do is to define the parameters within the model. And that is given by beta, which represents the disease transmission rate, and gamma, which represents the recovery rates per day. So I have run this too. And the next thing that I have to do is to define the time frame that I am modeling this disease. And I want to model it over 70 days and take time steps for each day. So that is what this code is doing. So I wanted to take a sequence from 0 to 70 and look at it for each particular day. I am going to write a function that returns the list of the S and the I as the next thing that I do here. So the function include time, the states, and the parameters. And I also include the differential equation for the S dt and the differential equation for the I dt. And I ask R to return it as a list here. So I am equally going to run this function. And the next thing that I do is to input the function times the state values, the time frame, and the parameters in the differential equation function in R. So that is what I did here. And this code is to help me combine the column for S and I by time. So let me quickly run this one so that we see how it is appearing. So when you run the output, you should get something like this. So it gives you the column for the time, the column for the susceptible, proportion of susceptible, and the proportion of infected. And the next code here is simply going to group the susceptible and proportion of susceptible and that of the infected by time. So let's view that too. Yeah, now this is how it appears. Okay, good. Okay, so the next thing is to plot our graphs. And I'm going to use Ggplot function that is in the Ggplot2 package. So I am taking this data, output data, and I want the X variable to be time and the Y variable to be that of the infected. So I plot this line graph and I'm going to zoom in. I'm going to zoom in, and this is what we have. A nice plot of the proportion of infected over time. The next thing is to do is to plot the proportion of susceptible over time. And I do that with this code. I can also see the nice plot for proportion of susceptible over time. And the last one is to look at both the susceptible and the infected together on the same plot, which I do that with this code here. So with this one, I am using the output full and the X variable as time, the Y variable as the value for both the S and the I. And I am going to group it or color it by the variable, and then color it by the variable and also group by the variable. And the others are the same code that I use. Okay, so let's zoom in to see how it looks like. This is what we have as the SIS model. I hope you enjoyed this tutorial. If you have questions, feel free to put it in the chat section, and stay tuned for the next video